We're going to start and finish in Acts chapter 17 tonight because it both lays a basis for what we're about to talk about this evening and also leaves us with a challenge. So if you have a look at the couple of verses that we read tonight, picking up in verse 24, it says this: God that made the world and all things therein. So here's a statement which is a very clear statement that God is the creator of both the world and everything that is in it. And then he emphasizes that again in verse 25. In the second half of the verse it says, seeing he giveth to all life and breath and all things. And in case we were wondering about mankind, he includes mankind in verse 26 and says, and hath made of one blood all nations of men for to dwell on the face of the earth. So here's a very clear statement that the Bible claims that God created the earth and all living things on it. So that's a very important basis for our understanding and our lecture tonight. The title, as you can see, is The Wonder of Creation, Proof of Divine Design. We do not believe, Christadelphians do not believe, that the theory of evolution or any variant of it is an adequate explanation of the origin of life. And the flip side of that coin is that if we look at the actual creation itself, it gives us stunning testimony of the fact that a wise and intelligent creator actually put effort and thought into the design of every living thing. So that's essentially the focus of our lecture for this evening. We believe that the Bible is the inspired word of God, that God exists, and that he has given us the Bible as his communication to us. It's not our purpose to try and prove that tonight. There are lots of other opportunities to look at that as to why we believe that the Bible is the communication to mankind from an almighty creator God. So that we're taking that as given for tonight and building on that. All right, so we're going to quote a number of times from the Bible, and I'm beginning with a couple of quotes here. You may care to turn them up, or you can simply look at the screen. The first one is just another clear statement that God created all things. Revelation 4 verse 11 says, Thou art worthy, O Lord, to receive glory and honour and power, for thou hast created all things, and for thy pleasure they are and were created. So not only does it say that God created all things, but it also gives us an inkling that God did so for a reason. And that reason, he says, is to give him pleasure. And there's quite a lot more in the Bible about that, and we could expand on that if you're interested. The second point is that God's power and divinity can be appreciated by looking at the natural creation. And we're hoping to have a pretty decent look at a few examples this evening. Obviously, in the time we've got, only a small number of examples. The Apostle Paul wrote in Romans chapter 1 verse 20, For the invisible things of him, that is God in context, since the creation of the world are clearly seen. Note that it's not like we don't have to stretch it. It's clearly seen, being perceived through the things that are made. In other words, the natural creation. Even his everlasting power and divinity, that they may be without excuse. So if we read that verse again and have a bit of a think about it, what it's saying is this: that no man or woman can say that they had no reason to believe that God exists, because the very creation itself should put their minds in that direction. God's eternal power, his divinity, his very existence is clearly perceived, Romans says, through the things that are made. So we're going to have a look at some of the natural creation tonight with that specific goal in mind, to have a look at the way that they are designed, the way that they act, and to think about, how could these have come about in any other way than that they are divinely designed with a high level, incredibly high level of engineering and ingenuity and beauty. Now, the next one is a quote from Job in the Old Testament, and it's actually God speaking in chapter 38 and verse 36. It says there, God says to Job, "Who has put wisdom in the inward parts, or who has given understanding to the mind?" We believe that God created all instinctive behaviours and interrelationships between the creation that he made. So when the spider spins its web, having never been taught how to spin, we believe that that behaviour was programmed into the spider by its creator. Just one example of many. And we'll look at some pretty remarkable examples tonight. The next quote is from Psalm 104 and verse 24, where it says, "O Lord, how manifold are your works." In other words, what a huge variety of things you have made. So the psalmist is just thinking about the incredible diversity of the creation that God has made. And he comments, "In wisdom have you made them all. The earth is full of your creatures." So again, very similar to Romans chapter 1, the psalmist says, it's pretty evident that the way that things have been made demonstrates God's wisdom. So you can see there's some quite strong statements here in the Bible. So when we turn to nature itself, we discover that nature, everything in nature operates within a framework of natural laws. The laws, of course, that we believe God made. And looking at the natural laws, that's a whole other lecture subject. Okay, but it's fascinating in itself that the natural laws themselves are testimony to a brilliant mind in behind them. All designs have functional efficiency. We don't find creatures that are pathetically incapable of living and just struggling on, maladaptions that just don't work, unless they themselves have been damaged by some kind of mutating force, chemicals or radiation or whatever. Yes, we can find mistakes due to damage, but the actual design of the animals and plants is remarkably functional and efficient. And in addition to that, over and above what is needed for functionality, we find beauty and incredible specialisation far beyond what is necessary for survival of the fittest. And we believe that that is evidence of not only an intelligent design, but a designer who delights in beauty. Because there's in many cases, the added beauty does not add function. The systems that God has put in place upon the earth have a wonderful balance. So even within the human body and within all living things, there is this wonderful balancing of processes. So within the human body, we have this process that's called homeostasis, where we have feedback mechanisms which the body uses to keep within a stable boundary of limitations. So as an example, of course, if we get too hot, we sweat. and our body, their sweat evaporates and we cool down. If we get too cold, we shiver and the muscles generate metabolic heat and we warm up. Just a simple example of the incredible functionality of the body that God has made. You could study that in detail and be amazed at the design that is behind it. But, even the smallest animals and plants incorporate very complex design features, often incorporating advanced mathematics that mankind has spent centuries finding out about. Mechanical engineering, chemical engineering, which mankind struggles to emulate. And I say emulate because mankind cannot get to the level of efficiency and the scales that the divine creation does. If we want to produce a chemical substance, we have to make a factory. We have trucks and railways bringing in raw materials. We've got to work out what to do with the waste. We've got to have a source of energy. All of those things happen at minute scale in a single cell at room temperature every day, day after day. Incredible. So even the simple things, when we look in detail at them, are remarkably efficient and effective. And of course, many organisms demonstrate an interdependent relationship with other organisms without which neither could survive. And it's extremely interesting, and we will look at just a couple of those. Okay, so I thought we might start by having a bit of a look at carnivorous plants. They're always interesting, and we have a few in Western Australia. There's the Albany pitcher plant down in the south, and of course we've got sundews and things like that. These are remarkable plants, which of course, in addition to being green and being able to photosynthesize, they have the ability to trap and digest animals. Here's an illustration of one that it's a sundew magnified. You can see the insect in there. The end of the sundew has curled right over the top, ensnaring the insect. And you can see that all of the little, I'll call them tentacles. I don't know what the proper name is for that, but they've got these little sticky ends on them which exude a liquid that's sticky and obviously attractive to the insects, but also they have the ability to absorb the nutrients from the insect through those very same apparatus. And we might just think for a moment about the complexity of that, not merely how the plant itself. You imagine if you're a believer in evolution and you've got an ordinary plant that's photosynthesizing and it's not in good soil, which these generally grow in fairly barren soil. There's plenty of it around Perth, sandy soil, and they grow in nitrogen deficient areas, so they use the animals as a source of supplementary nitrogen. And so they can not only exude this liquid, but also absorb the nutrients from the insect. We actually just think about that for a moment. You imagine this plant, the very first, if we go down the evolution line, let's just imagine this plant that's got a need for more nitrogen. And what it needs to get that, to be able to trap that fly, is to have a whole lot of sticky tentacles growing all over it, okay? But of course, if it grows those sticky tentacles by some amazing feat, that's not enough, okay? It's actually got to be able to attract the insect. And so it's got to have some kind of scent, a chemical substance that will attract the insect. So it needs a little factory to manufacture that chemical. But that's not sufficient, because even if it does manage to attract the insects and they stick onto the sticky parts of the sundew, it's got to have some other chemical that will dissolve the nutrients out of the insect. And that chemical, of course, has also got to be manufactured in the sundew. Now, assuming if we believe in evolution, we have to assume that the very first sundew didn't have that. So not only did it have to get its tentacles and its sticky liquid, but it also had to manufacture the dissolving chemicals that dissolve the insect. Now, that's a pretty amazing thing, but that's not enough, because it might have dissolved the insect, but it's also got to be able to then absorb those chemicals back again to be able to process the chemicals out of the insect. All of those things are necessary at once. And if any of them are not there, the plant will not function. It's just simply superfluous. Now, if we think that's kind of crazy, then if we go one step further and have a look at the Venus flytrap, we're looking at something extraordinarily more complicated. Now, I do actually have a video here.
What if plants could count? The Venus flytrap can, in a way. It's carnivorous, and it waits for an insect to fall in its trap and trip its trigger hairs. Each time a hair is disturbed, an electrical signal travels along cell surfaces. Scientists wired a flytrap with electrodes so they could see this process in action. Each flick produced an electric signal called an action potential. It took 2 flicks within the space of 20 seconds to make the trap snap shut, and more than 3 flicks to start up the cells that make the digestive enzymes and dissolving the prey. And the more times a frenetic, struggling victim trips a trigger hair, the more such juices flow. Now that's a smart plant.
Okay, now, I don't know whether you could hear all of that, but let me just point out a couple of things. So, he mentioned the fact that there are 3 trigger hairs on each of the 2 faces of the trap. We'll call it the trap. And if you touch one of those trigger hairs, nothing happens. You have to touch 2 of them within a relatively short space of time before the trap will shut. And did anyone hear what the time was? Could you hear or not? 20 seconds, that's right. So if you tap and then 30 seconds later tap again, no deal. It'll ignore you. And so what that does is it means that if a drop of water, for example, falls on it, or a leaf from a tree falls and brushes it, it won't waste its energy closing. Of course, it closes extremely fast. It's got to close quickly so that it actually catches the insect. And so these overlapping fingers on the ends of the sides of the trap actually allow it to close quite quickly and ensnare the fly or other insects. In fact, they catch a lot more spiders and ants than they do flies, but it traps them relatively quickly. Interestingly, if you get a piece of cheese, if you drop a tiny piece of cheese or an oat or something like that into a Venus flytrap, tap it a couple of times, it will close. It will sit there, and after about half an hour, it will open up again because there was no struggle. So it's actually the third and subsequent taps that actually indicate that it's caught something, and then it closes tight, seals itself up, and pushes out its digestive juices and starts the process. Interestingly enough, the 2 sides seal closely enough for the juice to come out and effectively turn it from a mouth into a stomach. And so it holds the juice without the juice running out and digests the insect. Then it absorbs the nutrients back into the plant, and then it opens up again. And the wind generally will blow the chitin shell of the exoskeleton of the insect away. So it's a pretty remarkable process. And again, we just have to think for a moment about how could this come about. So the snap trap either fully works or the plant dies from lack of nitrogen. And it's interesting that in Genesis chapter 1 and verse 31, I've got it on the screen, at the end of the creation period, after the 6 creation days, we read in the Bible, it says, "And God saw everything that he had made, and behold, it was very good." Now, very good indicates that all the bits were working. And that's really important, because there are some who believe that, yes, the Bible is from God and that God created everything, but they believe that he just kind of set things going and evolution took off after that. Not so according to the Bible when we actually read it. God made everything in a very good state. And the flytrap is exactly that. It's a beautiful design. And I've just put down 10 things there that are features of the flytrap that are so necessary. It's got to have this incredible hinged set of leaves, modified leaves. When they're open, they're actually convex. They're shaped like this. So that opens as wide as possible, and when they close, they actually become concave. They change shape so that they can create a chamber for the insect to be trapped into. You've got to have your movement sensors, 3 on each side, okay? So not just one, you've got redundancy built in there, and you've got the opportunity to eliminate false triggers. That's intelligence. You've got to have a closing mechanism that is quick enough to catch the insect, because if it closed but it took half an hour, by that stage the insect would probably have crawled or flown somewhere else. You've also got to have an opening mechanism that allows the plant, the trap to open again. These overlapping spines, absolutely essential, because otherwise the insect would most likely be able to crawl out. The timer mechanism that was mentioned on the video. You've got to have the ability to excrete digestive juices. Now, that in itself is amazing, because those digestive juices, a bit like our stomach acid, I don't exactly know what the composition is, but it's got to be powerful enough to dissolve the insect, but not able to dissolve the plant. So again, critically important that the plant can manufacture those chemicals. And that is a manufacturing process. The plant has got to be able to find the raw materials. It's got to be able to manufacture that at normal operating temperature. And it's got to be able to then use it to store it and to make those chemicals come out in the right place at the right time. It's got to have a good stomach seal, because otherwise, if it exuded all the digestive juices and they ran out the bottom, it wouldn't dissolve the insect. So that's why it's so important that the two sides are a beautiful seal when they close. The fingers overlap and you get a nice tight seal that can fill up with fluid, just like a stomach. Then, of course, you've got to have an absorption process. And you've got to have a transport mechanism to take the nutrients that have been absorbed out of the dissolved insect back into the plant. And of course, you've got to have the rapidity of closing that's necessary in order to trap the insect. You know, take any of those away, and it's useless. And so it just defies the mind to believe that one day a plant grew and all of a sudden there was a Venus flytrap on the end in full operating mode. It simply defies any kind of reasonable probability. And if you've studied anything about probability, you will know that very quickly, even the very simplest things, the probability rapidly ramps up with powers of 10 that exceed the number of atoms in the known universe. It's simply impossible. Okay, then of course there are a whole lot of other interesting carnivorous plants, and we're not going to say anything much more about these because we don't have enough time. But I did read one fascinating thing about these pitcher plants, and that is that, again, they have a bit of a fail-safe mechanism. So if ants are one of the favourite things that the pitcher plants trap, and they crawl over the edge here, and it gets a bit steep, but ants are really good at walking on vertical surfaces, no problem with that. So what happens is they crawl around on the pitcher plant, and if it detects one ant, it ignores it. If it detects two ants, all of a sudden this slippery liquid, a bit like what you would have on a slippery slide, is exuded from the leaves, the modified leaves, and the ants simply cannot hold on. Down they go, down the slippery slide. But it's quite fascinating that it won't stimulate the liquid flow until there's several ants running around on it. Again, indicative of design and efficiency. You know, seeds are, of course, a critical part of the reproductive process for flowering plants. It's very important that seeds be scattered as widely as possible. If all the seeds fall straight down under a tree, they will be shaded by the tree, and the new seedlings will be in direct competition with the tree. And there's all manner of ways in which seeds are able to be dispersed. It's quite interesting to look at some of these. A lot of them are carried by the wind, some are carried by insects, and others by animals like this bird that's eating the fruit. It eats the fruit, can't digest the seed, it goes to the toilet somewhere else, and the seed is deposited with its own little package of fertiliser ready to go. So the one in the middle, of course, is wind. These are wind carried, and they're just beautiful parachutes, perfectly designed to just float across and to spread, to cover an area to maximise the chance of being able to reproduce well. But over on your left-hand side of the screen, some very interesting seeds. And I've got a little video for that, which I'd like to show you now. I'll leave it.
Want to see something that'll make your eyes pop right out of your head? Watch closely. These remarkable mechanisms, seldom observed at this magnification, are engineered and constructed to help ensure life on Earth. They are biological wonders, commonplace but extraordinary, devoid of muscle tissue, yet surprisingly dynamic. And their mobility has fascinated researchers from South Carolina to South Korea. This story begins with these small lavender flowers. The plant's scientific name is Erodium cicutarium, but it's commonly known as stork's-bill. A week after blossoming, the petals wither to reveal these green striped pods. Inside the protective walls, 5 seeds quickly develop. Each seed is attached to a slender tail called an awn, and 5 awns per pod cluster together to form these narrow pointed extensions that measure 1 to 3 inches and resemble, you guessed it, the bill of a stork. Later, the pods die back to display their contents. 5 exquisite packages of life, signed, sealed, and ready for delivery. The stork's bill now awaits the most explosive stage in its life cycle. As the seeds mature, the awns dry out and contract. In the process, elastic energy builds within them to the breaking point. The extreme torque generated by the twisting awns catapults the ripened seeds away from the parent plant. Now things really get interesting. Once on the ground, the awn reacts to humidity and quickly changes shape. Its cells are hygroscopic, so even though they're dead, they still respond to variations in the weather. On a dry afternoon, the cells shrink and the awn coils tightly. But when the humidity rises, the moist air triggers an opposite reaction, and the awn uncoils. These alternating cycles of contraction and release produce motor action that causes the awn shaft, tail, and fine hairs to move the seed on its slow, relentless march. If the seed head locates a small hole or crack, it enters, then twists and burrows like a miniature bulldozer. Okay, now freeze the action right here. I want to show you why that seed's outer casing is an absolute masterpiece. Just look at its shape, sleek, tapered, and perfect for pushing its way into narrow spaces. And that hook on the tip, it anchors the seed while it's drilling into the soil. Those rows of microscopic hairs are aligned to help drive it forward, even in rough terrain. While large cavities on top of the case collect moisture that may help germinate the seed inside. This is a complete package, with every module working together, so the seed can literally plant itself. But there's more on display here than just a fascinating biological system. Consider this. Our world is filled with superb technology, highly efficient devices no one would reasonably attribute to chance or any random process. Instead, we universally recognize these machines as the products of purpose, design, and sophisticated engineering. So why can't similar logic be applied to nature? When we objectively study a mechanism like this, with an array of integrated components that result in nothing less than the generation of new life, there is only one realistic explanation for its being. The foresight and ingenuity of a mind that exists outside the natural world and created everything within it.
So hopefully you found that impressive. I certainly do. I used to love watching those things and just was amazed at how well they are able to drill themselves into the ground. Even the way that as they curl around, they've got all these little fine spines that tilt the seed up, keep it tilted up so that it can get the maximum chance of drilling into the ground. All of those things are strong evidence for design. Now, these creatures are rather weird, and often we don't see this kind of thing. This is a very special example of a slime mold. Slime molds are rather yucky things, and you will find them usually in very damp places, maybe under a piece of wood that's been lying out in the garden or something like that. Often in springtime, if you put a lot of mulch around in the garden, it's really, really wet and soggy. Sometimes you'll see slime molds. They are fascinating things. They come in all sorts of different shapes and colours. These are the fruiting bodies of the slime molds. And for a long time, there was debate as to whether they actually were plants, fungi, or actually animals, because at one stage in their life cycle, they actually can move around. They look like a slimy sort of not exactly a slug, more like a slimy splat. And but they can move around, and they do. They go from place to place feeding. Well, they are rather fascinating, and this is, for those who like a bit of biological detail, there's a life cycle diagram for you. They are actually a kind of amoeba. So they have a single-celled form. They're called plasmodium. But in the right conditions, when it's reasonably damp, many thousands, probably millions of them will gather together into a great big clump. And instead of being lots of individuals, they become one organism, and they move around as this slimy mass of protoplasm. And that's usually when you see them. When it starts to dry out, they actually get quite hard get like a hard crust on the outside. They form spores, and the spores eventually will, or spore cases, sorry, the fruiting cases will then open up later on, and they'll release the spores, which, when it's damp enough again, the spores can last through a hot, dry summer, and then when it's damp again, the spores will open up and release these amoeba, which have both an amoeboid form and also a little flagellated one, which has got a little tail that can move it around, and they can fuse together to form a fertilized plasmodium, and it starts the process all over again. Quite complicated, but very fascinating little creatures, or things. It's hard to call a creature. Here's some more pictures of them. Okay, so we'll leave that one there. But it's worth I just thought it was pretty amazing. And if any young people here have done year 11 and 12 high-level maths, they learn about analysing the shortest path between a number of different places. And it's actually, there's quite a lot of maths involved in doing this, especially when you've got multiple combinations like it showed there on the video. It does require a reasonable amount of intelligence to do that. And as you saw on the video, the slime mold was able to map the most efficient path for interconnecting all of those little pieces of food. And yet the slime mold is just a bunch of amoeba. They don't have a brain between them. They don't have any coordination. And when they finish, they're all separate. The process is gone. There's no organising power that we know. So the question is, how do they do this? How is a slime mold able to solve a maze efficiently? Like, that is truly amazing. And the answer has to be that God has put wisdom within these creatures. And obviously scientists will do lots of investigation, but the bottom line is that there are amazing abilities within every plant and animal. And you couldn't get on, if you're an evolutionist, you can't get something that's a lot simpler than an amoeba. That takes you right back to Darwin's sort of starting point. And when you find slime molds with those kinds of abilities, it blows his whole idea out the window. Let me just touch on a couple of other things before we wind up. There's never enough time in something like this. Mimicry, a fascinating thing. That is actually a leaf insect. You can see it across the top there. You can see its antennae, its body coming across to the right and its tail going over the top. I've got some at home, except they're not coloured like this. Ours are just a boring brown colour. But they're about as long as my hand. They're quite long, and the kids at school love them because they'll just sit there on your hand. But they don't just sit still. They will sit there, and when they're relaxed, they'll just move. They sway gently from side to side. What they're doing is they're mimicking the leaves. They're used to sitting on the leaves, being near the branches, and they'll just sway like a leaf, like as if there's a little bit of wind, a little bit of breeze, and they just sway. So not only has it got a body that's actually camouflage, it has behaviours that match its environment as well in order to help it survive. Truly remarkable. And again, you imagine how big the brain of one of these creatures is? Like, we're not able to change ourselves just by thinking about it. Jesus said that. He said you can't make one hair of your head black or white. And yet these tiny insects are so remarkably matched to their surroundings. Okay, here's a few more. The one on the top left is one of my favourites. It's actually a gecko, which is incredibly like a dead leaf. Not just in the shape of its body, but also in the colouring, even the venation. It's like fake veins, leaf veins on the outside of its body. Beautiful. This one down here on the bottom left is actually a praying mantis, which lives in an orchid and is incredibly well camouflaged. Again, my background is in chemistry, and every time I see something like this, I think of phenolphthalein. So an acid-base indicator, a bright pink colour. But, you know, to produce a chemical substance that turns their bodies pink like that, I don't know of any other mantids that are like that. So it actually had to manufacture a new chemical substance. That's no small feat to be able to do that within its own body. Not only making a new chemical substance, but it had to match. It's no good if it suddenly learnt how to manufacture a purple colour and it's on a pink orchid. That's totally useless. It's got to be able to manufacture the pink colour. And truly amazing. This one down here is a toad, and you can see it's a mixture of green and brown and beautifully camouflaged. And these could be multiplied in examples many, many times. I don't think we have time to look at the fig wasp. The strangler fig lives in tropical rainforests. It's called a strangler fig because it climbs up other trees in order to get up to the top to get some of the light. It has figs, but amazingly enough, there aren't too many flowers in the rainforest up at the top of the foliage up there. It has a problem with pollinating its figs because the flowers are inside the fig. And a little wasp does the job for it. Actually, you know what? We have got a couple of minutes, so I'm going to play it because it'll take me longer to say it than for you to.
High up in Borneo's canopy, you'll find a fig tree living in symbiosis with an outlandish wasp. One who is willing to sacrifice her own life to assure the survival of her offspring. Competing for sunlight in the dense rainforest, the strangler fig takes advantage of other trees to find its way up and exploit the pole position in the canopy to reproduce. But for this, it depends on a bizarre creature that you might have never even heard of, the fig wasp. This minuscule insect is just around 2 millimeters long. The wasp's life cycle is deeply intertwined with the fig. She knows that the only way to get into the fruit is through a tiny hole on the bottom. She has to sacrifice her wings in order to get through the tight nozzle. But she won't mind, as she knows that she'll never fly again. Once inside, the strangler fig shuts the entrance to its fruit. Thus, the final act of the wasp's life is to lay her eggs in the cavity. After that, she will die in there. Over time, the flowers and the wasp eggs develop, and the fig transforms into a mature fruit. From the eggs, however, male wasps emerge first. They have no wings, as they won't need them during their short lives. Their life's purpose is limited to 2 goals only. The first one is to mate with the females. They do this by biting their way in and inseminating the younger, still not fully developed females. As soon as they've completed their first task, they tackle their second and last job, digging a way out of the fruit. But this escape route is not meant for themselves. Without wings, the male wasps have no chance of survival on the outside. Their final hours are numbered. Inside, their sisters now emerge. Already fertilized, they head directly for the exit, being brushed with pollen on their way. With ready-made tunnels dug by the now dead males, the females have an easy way out, so the pollen remains glued to their bodies. Their lives won't be that much longer either. They can live for about 2 days only. But these 2 days should be enough to find another strangler fig ready to receive them. The minuscule wasps are in fact top-performing creatures. They can fly up to 50 kilometers above the canopy. Drawn in by the scent of receptive figs, they will find a new host for their offspring. Here, the game reboots. The wasps find the small opening and enter the fruit while pollinating the flowers at the same time. The strangler fig and the wasp depend entirely on each other. A bizarre partnership that has been going on for more than 60 million years.
Well, we do disagree with that one, the 60 million years bit, because according to God and the Bible, the creation was only about 6,000 years ago. And we have very good evidence to believe that the Bible is right. So there are so many examples of interdependence. And again, it shouts design. It shouts design, the way in which the fig is designed for the wasp and the wasp is designed for the fig. I won't be able to go through the detail of this. The leafcutter ants are an amazing example of interdependence. There are 3 parts of this at least. The leafcutter ants, of course, cut leaves, take them back to the nest. The leaves themselves, they cannot eat. They're completely unable to digest the leaves. In fact, many of the leaves are toxic to the ants. They have amazing jaws with serrations on them, exactly like a saw. And they move them at about 1,000 times a second to saw them extremely efficiently. And they predate these leaves and take them back to the nest. In the nest, they give them to worker ants who will chew them up into a mulch without actually swallowing any of it, and then it's fed to a fungus that grows inside of the nest. The fungus grows very well on the diet of mulch leaves, which the ants feed it and tend it. They move the fungus around, they move the leaves around in order to keep the fungus growing. The fungus is the ant's food. The big danger in a closed environment, which is warm and moist like that with lots of fungus, is that the wrong kinds of fungus will grow. The ant on the left is covered with a white substance, and scientists have discovered it is actually bacteria, and the bacteria on the ant's body exude a powerful antibiotic that will actually kill other dangerous fungi and bacteria that enter the nest on the ants' bodies. So quite a remarkable situation. And in fact, scientists are now looking at seeing whether they can make new antibiotics from these the antibiotic chemicals that they've discovered on these leafcutter ants. Don't have time to talk about Fibonacci sequence or the golden ratio in plants. What we are going to do is we're going to finish by looking at the logical appeal to us. If the natural creation is a witness to the existence, the power and the wisdom of God, then we have no excuse for ignoring the evidence that God exists. In actual fact, that's what it says in Romans chapter 1 and verse 20, where we read it before, but look at the last bit. It says, so that they are without excuse. When we look at the natural creation, we see the evidence of design. It should convict us. We're without excuse if we do nothing. And that's where we come back to our reading that we began with this evening. Come over to Acts chapter 17 and verse 30. Or I've got it on the screen. From 30 and 31. Truly then, God overlooking the times of ignorance, now he strictly commands all men everywhere to repent, because he has appointed a day in which he is going to judge the world in righteousness by a man whom he appointed, having given proof to all by raising him from the dead, none other than the Lord Jesus Christ. We believe that Jesus Christ is coming back to the earth. He will judge the world, as it says there, in righteousness. We are being given opportunity now to recognize that there is a God, and now to come to know him. To come to know him, to love him, and to walk in a way of life that is pleasing to him, so that when Jesus does return, we may have hope of everlasting life. And I certainly encourage you to look further into those things.